Good morning. Uh, my name is Nouri. Uh, Today I'm going to discuss about geometric design for a terrain condition. So we already discussed about the geometric designs. Those are uh, here we are studying about the terrain conditions only. We already studied about the geometric designs of different definitions uh, ra- carriageway, shoulders, and formation with right of way. In that, we have seen the carriageway is nothing but the width of the pavement and depends on the traffic line. So, that is about the carriageway where the vehicle moves on. That is the carriageway, and generally its width will be for national highways 3.75 for the single lane, and for the two lanes it's 7.7 meters for two lanes without the curve. With the curve, if it is there, then it is the 7.5 is the two lane routes. Next comes to the shoulders. We have seen about the shoulders also. Shoulders is nothing but it's mainly used for the parking space in emergency. Side of the road it is shoulder. It will be on either side of the road. You can say, okay, that will used for uh, uh, for the lateral stability for the carriageway. Okay, it's after the carriageway in the at the edges, shoulders will be there. So any emergency for the vehicles, there we can park it and we can do it. That is about the shoulders. Next, we have seen about the formation width. Formation width is nothing but the width of carriageway and the width of shoulders. Formation width is sum of the width of the carriageway and also width of the shoulders on either sides. So that is called as a formation width. And in the formation width, we have seen as per the IRCs for national highway for a single lane in plain terrains, it's a 12. It should be there, and for the mountains and the steep valleys, it should be 6.25 for the single lanes. Like that we have seen ISC, as per the IRC codes, we have seen the different uh, different limits in them. Next comes to right of way. Right of way is the area where land is acquired and reserved for the future development. That is the right of way. So in that, we have seen, as per the IRC, the width of right of way should be for the national highway should be for open areas 45, and for the mountain areas it should be 24. Like that, we have seen different mm, uh, for the different areas. We have seen the right of way also. Next comes to the camber. Camber or can say has a cross ball or can be seen has a cross loop. So the camber is a rise given to the center of the carriageway. So for the we already discussed carriageway. That is nothing but you can say in the words as a road. So where the vehicle will move, that is called as a road, or can be called as a carriageway. Camber is nothing but that carriageway has some slope, little gradient. So that slope, the the slope is nothing but the uh, rise of the center line. You can say that the rise given in between one white line will be there in the road. So that white line is nothing but the center of that road. So that will be little rise in the center, at the center. So that of the carriageway. So that is called as a camber. So why we will provide that cam that will provide means we generally whenever the water is there on the road, it should be drain off. So little slope if we provided, then the water will not stagnate and it will uh, run off and it will give safety for the road, and also next it will give the mm, protection for the uh, foundation of the road. So generally the shape of the camber may be parabolic or elliptic and straight. Okay, or in the combination of parabolic and the straight it will be there. So the main function of the camber is to drain up the rainwater, I already said. So what parabolic, generally it will be there. Why it is if it is more slope, if we provided more gradient, so heavy camber at heavy height, then what is the disadvantage? The will not the vehicle um, will not move at the center to the edge. But the vehicle generally goes to the edge of the road, and it will try to move on the center only, center of the road. So that it will cause damage to the road. So for that we have to provide not more slow. We have to put a little slow. We have to see how one in vertical for around yeah, we should provide for the 2% like that, 1.7 to 2% of the height we have to, gradient we have to provide. Like that, we have to see for the bituminous and the cement roads. So those are the definitions of the geometric design we have seen. Today we are seeing the geometric designs only for the terrain condition. If it is in a terrain condition, what will be there? So before going to that topic, here's some introduction to that. So the visibility of the road of ahead of the driver will help in the safe and efficient operation of the vehicles. This will hence demand the geometric design to be highly efficient so that the length of the road is highly visible to the driver even from a distance ahead. So here what's the point we are saying? Visibility of the road to the driver will help him to be safe in operating the vehicles. So the visibility of the road is a main operation uh, for driving the vehicle in safe mode. So here this is the first geometric connection where we have to see. So it is highly efficient so that the length of the road is highly visible to the driver even from a distance ahead. So if a driver could see, he should be able to see from a long distance, not coming closer to the vehicle, and he have to see by coming closer means then the driver get be the way he will get some embarrassing of or panic at the time of the coming closer and seeing the dragons. If we have an idea of a long from a long distance only, then he can react what have to be do. Like that, the driver should see from a distance ahead. This distance is termed as the sight distance. So the a person who is going to try, if he is able to see from ahead, from a you can see from a point 5 meters or a uh, 1 meter approximately, then he can think about, okay, this is the vehicle in front of me, so I have to go by a side. I have to take a break. I have to take a turn. Like that, has an idea if he see from a head, a distance head. So that distance is called as a side distance. So in that, there are different types here we are going to see. So first one is the side, in the side distance, the actual distance that is observed along the road surface, which is visible for a driver from a specified height above the carriageway. So from the road, he should be able to observe the road surface, and also have that some height should be there. Specified height should be there, is called as a side distance. So some height for the vehicle height will be also there. So from the height, from that height he have to observe the road surface also. So that observing from a certain height is called as a side distance. This distance will let the driver see all the stationary and the moving objects in front of the vehicle. So when he was driving in the vehicle, so that he can observe from that height all the stationary and also the moving objects in front of the vehicle. So that height should be um, from the carriageway, we have to fix it. So that side distance is called as a that height from the carriage is called as a side distance. Next, in that, mainly the geometric design of road construction, mainly three side distances are there. They are SSD, stopping side distance, are absolute minimum side distance. Next comes to ISD, intermediate side distance. This is twice the value of SSD, means stopping side distance, twice. If it is a SSD, for example, of 2 meters, then our intermediate side will be the 4 meters, twice. So OSD, overtaking side distance. So these are the three distance we are going to see. So in that, uh, these are the two, and also additional to this one, headlights side distance and safe side distance. Uh, the distance that is available for the driver during the night travel is called as an headlight side distance. So when a driver which is he is driving on the night, he should also able to see the objects in the night also. So the side, the distance that is available for the driver during night travel is called as a headlight side distance. So at night, the driver is facilitated by the illumination of the headlights. So there we can see lots of light will be there in the dark area. So without that, he cannot go safely. So that illumination of the headlight is also important. So next, the side distance available to enter an intersection is called as the safe side distance. So at he was entering at the junction also, he should have an idea uh, about the around the crossing which vehicle is coming to take a turn. So that side distance also he should have an idea. Whatever be the stopping distance taken into consideration, it is necessary for the driver who is traveling at a design speed to process sufficient carriageway so that this distance will be within the line of vision to stop the vehicle. So, stopping distance taken into consideration. So here SSD we have said no. So that is nothing but a stopping distance. So he should have a consideration. The driver who is traveling at a design speed possess sufficient carriageway distance. We already designed for a single line, it should be 3.75 meters. So the sufficient at a design speed he was traveling, that distance will be within the line of vision to stop the vehicle for colliding from colliding with a moving or stationary object in the traffic lane. So at the junction, he doesn't have an idea which the vehicle, what is the vehicle is coming or around at the turning. So that line of vision to stop the vehicle, he should have an vision. The line of vehicle colliding, there is a chance of it. He should have a vision to stop the vehicle at that location. So in this stopping side distance, this is defined as the side distance that is available for the moving vehicle in the highway that will enable the driver to stop the vehicle safely without collision with any obstacle. So, as the main parameter for this one is the safe stopping distance is the most important feature in the traffic engineering. So, here we can see the stopping sight distance. The stopping sight distance is nothing but you can say that is available for the uh, uh, if we applied any brake, okay, that will enable the driver to stop the vehicle safely without collision. Any stopping side distance, some distance should be there. If he apply brake, it will not stop at that location only. It will move forward. That stopping side distance should be there for a vehicle. So that is the main parameter, and that is the safe stopping distance. In the different. Safe stopping distance is the distance from the point it first pursues to the time the declaration is complete. So he will get a signal time. He in a minute, in a second, declare the declaration. He should stop like that. He will get a pursuance to the time the declaration is complete. So adequate time is necessary for the driver from them to react to the obstacle spontaneously. So this demand the side distance used in the geometric design to be equal to the safe stopping distance. So the time of the um, geometric distance for if you're designing a road for road, in that we have to see the side distance. Safe stopping system should be equal to the side distance, so that the stopping system can be defined as the sum of lagging distance to the brake distance. I mean to say, lagging distance. Said no, it should react. The reaction will take some seconds. So that seconds to be considered in the design system, so that the vehicle can stop and he can stop safely. Okay. So that should be considered. So that lagging distance to be considered. So the lagging distance is the distance that is moved by the vehicle in a time period that is called as a t at a velocity of v. So the applying reaction time, that is the t of the for a vehicle, that lagging distance we are calculating. So that lagging distance, the vehicle in a time period is the t at a velocity of v. So hence lag distance is the velocity into t. That is the distance. Okay, that is nothing but velocity into the t. So the distance that is traveled by the vehicle during the operation of braking is called as a braking distance. So what is meant by the braking distance? The distance traveled after the brake applied also. Uh, that distance is called as a braking distance. In case of a level road, the work that is done in stopping vehicle is equated to the kinetic energy of the vehicle, which will give us the braking distance. So, if it is a level road, so that will be applied for the kinetic energy. So, that kinetic energy for the braking distance. So, next comes to, so if we are applying means there we are creating some friction. Applying brake means having the velocity, it should have the time also. Where the distance is there, we have the velocity and the time. So sorry, mm, there F is the frictional force that is developed and I is the braking distance. So there we are developing the F and I. So F is the frictional distance, okay, and I is the braking distance. Frictional force and braking distance. We apply the force on the vehicle. Force is applied, and uh, brake force is applied means brake is done. So after the brake, the distance the vehicle move a little bit. That is the braking distance, and in that we are I have to add the weight also. So here we are calculating the weight of the vehicle. So the weight of the vehicle, there the kinetic energy attained at the design speed of the vehicle. So here Fi is nothing but the frictional force into the weight of the vehicle into the braking distance. This is the equation. So here we apply the kinetic energy we said no. So this is the formula what we will get of the stopping side distance Vt plus 1 by 2fg into v square. Okay, here we say Vt by v square by 1 plus v square by 2 fg. This is the formula where we will get the SSG. Here v is the speed in meter square, meter per velocity, and the reaction time. F is the coefficient of friction and g is the acceleration. So here g it is due to gravity meter per second square and v is the meter per second and the reaction time it's entirely in seconds only. And here all these were considered for the uh, formula. So uh, Vt plus 1 plus v square by 2ft. Sir, here some speed is there. For the speed for less than 0, it should be 0.5, and if it is 40, 0.38, let the friction as given. If the road poses an ascending gradient in an account equal to uh, um, percentage of the, here the percentage of friction is going on increasing to the braking action. So the component factor of the gravity will be added. This will decrease the braking distance. After equating the kinetic energy and the work done. So that is the formula 1 plus v square by 2g into f plus n plus 100. This is the where the energy. So he also derived the braking distance for a descending gradient that is same as stopping side distance equal to Vt plus V square by 2g f plus or minus 0.01 into n. So this is the formula, or it can be written as St equal to 0.278 Vt plus V square by 254 into plus f plus or minus 0.01 n. So this is the stopping side distance formula. Next comes to the overtaking formula. So overtaking side distance, here the minimum distance available for the driver to safely overtake the slow vehicle in front of him by considering the traffic in the opposite direction. So the minimum distance should be available for the driver to overtake for the slow vehicle in front of him. So that the distance is called as an overtake side distance. So this distance will make us see whether the road is clear to undergo an overtake movement. So if we're going to take an overtaking, means we have to have a visibility whether the road is clear to overtake or not. That much of distance we already see in the uh, geometric designs of carriageway width. As per the IRC, we've seen that single lane is 3.75 way, that the vehicle width is 2.44, and the side overtakes are there. Okay, for side overtakes that comes 0.68 plus 0.68. Both sides on either sides of 0.6. So that much of distance is provided to see whether the vehicle can take or not. Okay, so the overtake side distance is also called as a passing side distance, that will measure along the center line of the road. So this is the line level over which the driver keeping an eye level of 1.2 meters. So the carriage from the carriageway, the height of the person is considered as the 1.2 meters above the road level. So it can be easily see the top of the object above the road surface. So he on the moving vehicle he can see the objects at a height of 1.2 meters. So what are the factors affecting the overtaking? So first factor is nothing but the spacing between the vehicles. So if you want to overtake, the space should be there to overtake the vehicle. So spacing of the between the vehicles. Next, speed of the vehicle. If you want to overtake this, you definitely take a uh, speed of speed. He will increase the speed. Next, the gradient of the road. If the road is more steep compared to the higher center of the road to side edge of the road, then gradient is also be considered. The acceleration rate of the overtake vehicle. You can say whether he can go or not. Uh, Velocity of the vehicle, and also the driver's skill and the reaction of the driver. So all these, the driver also you have to think whether he can take or not. It will depends upon, hey, if it is a heavy loaded vehicle, then it will depends on the skill of the driver. If suddenly by taking overtake any unexpected like animals or like that, if it is there, then the reaction of the driver is also important at the time of overtaking. So, uh, for the in the side distance, we have seen that stop setting distance, intermediate side distance, and overtaking side distance. So depends on the all these for the side distance really depends upon the driver reaction time. So first main consideration for the formula we have considered SSD stopping set is 0.278 Vt plus V square by 254 into F plus or minus 0.01 N. That formula we have seen. So in that we have seen that first is the driver reaction time, vehicle speed. After reacting only, we can say the driver's vehicle speed and also efficiency of the brake, the frictional resistance existing between the tire and the road. If it is west, whether the road in weather conditions also you can supply. Okay, so on the weather conditions only, the tire and the road friction will be developed and gradient of the road. So all these factors will depends on the side distance. So in that we can see brake efficiency. So brake efficiency here, brake efficiency, many factors like age of the vehicle and the characteristics of the vehicle will affect the brake efficiency of the vehicle. So age of the vehicle, if it is old vehicle, then the brakes will not apply uh, fast. So it will take time. The characteristics of the vehicle and efficiency of 100% implies that the vehicle will stop at the moment has the brake applied. So obtaining 100% is not practical. This is an ideal condition of the vehicle. So we are the at the design we will think that the brake applied will 100% possible like that we will uh, design, but practically it's not possible. It is an ideal condition depends upon the vehicle whether the brake is sudden applied or not. So this means for a lower value of the brake efficiency, it is necessary to obtain a higher value of side distance. So, in the process of determining a safe geometric design, it will required to assume 50% brake efficiency. So for that purpose, for the applying of the brake braking, we have to take the we have to consider not 100%. We have to take 50% only. So next comes to the friction between the road and the tire. So we have seen here different factors are there in that brake efficient, driver reaction time and the vehicle speed, efficiency of the brake, and friction between the tire and road, and gradient of the road. So next comes to friction between the road and the tire. The stopping of a vehicle is also depends on the frictional resistance between the tire and the road. So that's it, no? So the stopping of the vehicle is also dependent on the frictional resistance between the tire of the road. Having a higher value of frictional resistance will result in efficient stopping of the vehicle. If we are considering the frictional resistance is more, then the vehicle stopping efficient is also when applied, then it will when applied only it will get applied to that vehicle. So here the side distance required will be less during the competition of the side distance. So no special provisions are required for the brake efficiency. So this is considered along with the factor of longitudinal friction. So in India generally we take the uh, friction, longitudinal friction, coefficient friction in between F has considered as 0.35 to 0.4. So this is the Indian IRC has recommended the value of the friction. Next comes to the speed of the vehicle. So the speed of the vehicle clearly affects the side distance. So if the speed employed is high, the time required to stop the vehicle will be high. So this means that with the increase in the speed, there is increase in the side distance. So it, uh, if you suddenly if you are applying the brake means it will the vehicle move a little, so that is called as a side distance. To require to stop the vehicle, it requires a little distance, that is the side distance is required. So next comes to driver reaction time. So the driver will have to react only, then only all these factors, I mean to say, to stop the vehicle. Stop the vehicle means to apply the brake. So all these two factors depends upon the driver reaction. So the time that from driver the time from the moment the driver observed the obstacle in front of him to the moment applied brake is called as a reaction time. So when he see the any object or obstacle in front of him, he reacted to apply the brake. That is called as a braking uh, reaction reaction time. So based on this PIEV theory, that will divide it into four components. So all this time will be combined to form a total perception reaction time while undergoing actual practice and design of highways. So that the reaction time will be 1.5 to 2 seconds from the normal conditions. So for a normal conditions, a person will react in between 1.5 to 2 seconds for applying the brake. Has this value vary based on the characteristics of the vehicle? So he will react it, and if you want to apply the brake also, it will depends upon the vehicle. Heavy loaded vehicle or also so it depends on the vehicle how fast he is going. So a higher value for the reaction time can be employed for the design purpose. As per the IRC, it will take as 2.5 seconds. So depends upon the person also. It may varies if a person, a child, a youngster or a whole person or like that in middle age, like that if the reaction time will also varies, perception time is also varies. So generally as per IRC, it is considered as a 2.5 seconds. Next comes to the gradient. So, what do you mean by the gradient? So, in geometric distance, we are considering the gradient also. The side distance is greatly influenced by the gradient of the road. So, there are chances of the vehicle to stop the suddenly when the vehicle is climbing suddenly. So, if it is the vehicle is going on the higher areas, climbing higher areas, these situations will ask for a small side distance. So when the vehicle is moving down, the movement is supported by the gravity action. So moving up and moving down on the hilly areas, it all depends upon the gravitational force. So this should be seen a balance. This will hence ask for a more time to stop the vehicle. So if the vehicle is coming down means if you apply the brake also it will not stop easily. So there we have to see how much gradient we have to provide for the road. That is more important. So they require the side distance is more in the case of the gradient roads, or you can say in hilly areas, there it requires side distance more. In before we have seen that side distance is have it should have about for the 2.5 seconds as reaction, and it will take uh, to apply the brake. But if we here we apply the brake also, the side distance should be more compared to the plain terrain. So that is about the gradient. So next comes to the intermediate side distance. Next comes to the intermediate side distance. So intermediate side distance, it is defined as twice the safe stopping side distance. It is experience that intermediate side distance affords reasonable opportunity to overtake with the caution. Next comes to uh, gradients. In that we have seen gradient is nothing but the defined as the rise or fall corresponding to the some horizontal distance, that is called as a gradient. So gradient with upward gradient, it is considered as a plus n percentage, and downward gradient is a in a negative. So if it is a positive means plus 1%, like that, plus 2%, like that, we will get a gradient. So that plus means rise. If we go for the minus, it will indicate the fall in horizontal distance. So with respect to the horizontal distance. So next comes to the different types of gradients. In this we are seeing the ruling gradient, limiting gradient, exceptional gradient, and minimum gradient. So first comes to the ruling gradient. Ruling gradient, this is a maximum gradient which is generally used to design the vertical profile of highways. So it also called as a designer gradient. So in this gradient depends upon the terrain, length of the grade, speed, pulling power of the vehicle, and the presence of the horizontal curve. So it is adopted by considering a particular speed is the design speed and for a design vehicle with the standard dimensions. So in flat terrains, it is possible to provide flat gradients, and in hilly areas, it is very costly, and sometimes it's difficult to provide the ruling gradient in hilly areas. So in this we can see it is an isolated, it is for the flat terrain, a ruling gradient where we provide. So the it is a ruling gradient generally adopted 2% for a angle of the aesthetic. So safety gradient up to the ruling gradient are adopted in normal course design. Generally, we will provide the normal ruling gradient only. So it will depends on the length of the grade and the speed of the vehicle which is coming on. So all this. So if it is provided for the hilly areas, then the gradient is uh, it is in flat terrains. It is possible to provide the flat gradients, but in hilly areas, it is very costly to provide the ruling gradient. So next comes to the limiting gradient. So the gradient which is shorter stretch, a little gradient is more, uh, uh, inclination is more, so that compared to the ruling gradient, so its cost is higher, and it's for hilly terrains. So there we have to provide the limiting gradient is provided, which will reduce the cost. This gradient is adopted frequently in terrains with limited stretches. So if you provide it for the plain terrain, it will be provided for the limiting stretch only. But a limiting gradient is generally suitable for the hilly terrains. Next comes to exceptional gradient. Exceptional gradients is nothing but a very steeper gradient given at unavoidable situations. So this is gradient is more. In this, the gradient will be more. It's generally we cannot escape to provide that exceptional. Then we will go for the exceptional gradient, and they are adopted for a stretch not exceeding the 100 meters. So 100 meters of length only we can provide, not more than that. And then comes to minimum gradient. To drain off water, so from the road, minimum gradient is camber. We have seen the camber. No? Minimum gradient is provided. It's generally for the lateral drainage. So camber is provided. But more for the longitudinal drainage along the side drains, it requires some slope. So for smooth flow of water, so for concrete drains, it will provide 1 in 500, and open soil drains of 1 in 200. Generally, we will provide for the concrete 1 in 500, and if it is provided for the soil drain, then we will provide 1 in 200. So its minimum gradient is nothing but throughout the longitudinal section. The camber is only for the cross section providing for the removing to for the movement of the drainage water which is on the road. So here the different gradients are given for the roads. So for the plain or rolling gradient, for the ruling and limiting and exceptional gradient, we can say ruling gradient should be 1 in 30, and limiting gradient is 1 in 20, and exceptional gradient is 1 in 50. And mountainous and steep terrain have generally 1 in 20 ruling gradient, and limiting gradient is 1 in 16.7, and exceptional is 1 in 14.3. And where the elevation is more than 3000 meters, or you can say the steep terrain, there we will provide the 1 in gradient as 1 in 16.7. So here we can see the limiting ruling gradient itself we are increasing 1 in 16.7, and here limiting should be 1 in 14.3, and exceptional is 1 in 12.7, so 8 percentage. So these are the next comes to the super elevation. So super elevation is nothing but to balance the vehicle on the road at the curve portion. So super elevation may be different as the super elevation may be defined as the one-sided uh, transfer slope obtained by rising the outer edge of the pavement with respect to the inner edge throughout the vehicle. So, has the curve to contract the effect of centrifugal forces. So here we are getting the centrifugal forces when a vehicle is overturning, there is a chances of getting off skidding of the vehicle. So centrifugal force will be there to uh, contract the vehicle at the turning places. So it is usually denoted either in fraction or in percentage. So superelevation is generally denoted in percentage or in fraction. So it is expressed as the ratio of the height of the outer edge with respect to the horizontal width. So here V square by uh, G into R equal to E plus F for the super elevation. So where is E is the rate of super elevation, and F is the coefficient friction, lateral friction, and V is the velocity of the vehicle, and R is the radius of the curve. Here we can see R is the radius of the curve, and G is the acceleration due to the gravity. So where the super elevations cases arise. So when the super elevation arising, F equal to 0. Here the formula we can see if F equal to 0, then E equal to V square by GR here. So this situation occurs when the centrifugal force is entirely contracted by the super elevation. So here friction. lateral friction will be zero. So lateral friction will be zero. Then the centrifugal is a occurs that will be contracted by completely super elevations. So in this ideal situation, a moving vehicle will steer itself about the super elevation curve once its wheel have been set on the road track. This super elevation is called as an equilibrium. So this result when the pressure on the outer and the inner wheels are same. So this will be obtained a very high, and thus it will be desirable for fast moving vehicles but is exceptional for slow moving vehicles. So this lateral friction zero is applicable very obtained very high, and thus it will be very desirable for the fast moving vehicles, but it is objectionable for slow moving vehicles. So it is not for the slow moving vehicles. Next, E equal to 0. Next comes to the E equal to 0. So E is nothing but the super elevation ratio. So when E equal to 0, then F equal to V square by G into R. So the situation occurs when the frictional force fully counteracts the lateral force. So such cases may arise when there is no provision of superelevation. So where there is no superelevation, then the factor of friction is mm, applied. So it will be a design of intersection. So where there is any two roads are intersected crossroads, there the super elevation will be zero and friction will be developed. So this will develop the E equal to 0 and F equal to 0.15. That equation will becomes a VB equal plus root of F into G into R. So VB is nothing but the stress speed. So that's this where the super elevation getting zero means there the speed is restricted. Next, maximum super elevation. So in a highway with the mixed traffic, the value of super elevation so obtained from equation is to be limited to avoid the danger of overturning. So this maximum allowable limit is 7% for plain area and for the 10% for the hilly areas. So if it is in the urban road, then it is 4%. So it was restricted that how much super elevation is to be provided for different terrains we have seen. A minimum super elevation is to be if the value of super elevation obtained from the equation is equal or less than the usually the camber value provided to the road surface, then it should be equal to the camber slope. Data should be equal to the amount of camber this term has minimum super elevation. It is 2 to 4% for drainage purpose, especially for the large radius horizontal curves. So for the any curves, minimum super elevation has to be provided. So if it is a large curve, minimum have to be provided. That is 2 to 4% for a why should provide for a drainage purpose. Next comes to what are the advantages of super elevation. So it permits a vehicle to travel at high speed without danger of side skidding and overturning. So if we provide the super elevation at the turning or at the curves, then it will provide a safe turning for the vehicles which will contract with the gravitational forces. So it will balance equilibrium that vehicle at the turning places. So the further purpose will provide the super elevation. The load on wheels are distributed evenly, hence less wear and tear of tires will be occur. So it helps the vehicle to keep in a proper side of a pavement and avoiding the tend to travel to the inside of the lane. So here we have say E plus F V square by 127 by R. So here we have covered about the super elevation. So super elevation is provided to achieve the higher speed of vehicle. It increases stability of a moving vehicle when they pass through a horizontal curve also. If we pass through the horizontal curve, it should have a stability also. So for that only we are providing the super elevation, and it is also decrease the stress on the yes, on the foundation also, because if the vehicle speed is more and if the load of the vehicle is not distributed, means the more burden is on the foundation. So the factors depends on the transitional rate on the super elevations are nothing but design speed, cargo radius, and number of travel lanes, how many lanes are coming. So that is also important factors for that one. Next, we have seen about the gradient. It is the rate of rise or fall of a road level along its length. So it is expressed as the either has the rate of rise or fall for the horizontal distance. So from the horizontal distance, we are rising the road rate of road rise or fall of a road level. So gradient is a measure how to steep. A slope or a line. So gradients can be calculated by dividing the vertical height by the horizontal distance. So how gradient is we are calculating by the vertical height and divided by the horizontal distance. There we calculated with the gradient. So in the gradient we have seen the different types: ruling gradient and limiting gradient, exceptional gradient, and the minimum gradient. Ruling gradient is the general gradient which we already provided. Limiting gradient generally we provided for the hilly areas. Exceptional gradient, it is not allowed. If it is allowed for only 100 meters, we will provide. Minimum gradient is nothing but generally a longitudinal. If a longitudinal section, we can provide 1 in 500 like that, and for the open areas, it can provide for the 1 in 200 like that we will allow for the longitudinal section. If we will provide a gradient of a cross section, that is called as a camber. So in the design geometrics, we have seen about the stopping side distance and also overtaking side distance and intermediate side distance. And that all this we have today discussed about this all these topics.